This is another type of straight line graph question, or some students call it linear law question. This type of question are not difficult. The problem is it takes a lot of time to do. So we learn how to do this question quickly, because this type of question, they give you this data and you must draw points by points. Now we try this question and see whether we can do it quickly. Okay, I read the question. The table show experimental values of two variables x and y, which are connected by an equation of the form y x power n equals to k, where n and k are constant. They give you a table with the values of x and y. Using a scale of 1 cm to 0.1 unit on each axis, plot log y against log x and draw a straight line graph. Yeah, that's the first question. They ask you to plot log y against log x. This is, you have 4 data, you have 4 points. And I already copied to my pattern here. I have a pattern for the table. Then we must do calculation to quickly find the value of h, which is the horizontal axis, and v, which is the vertical axis. So we calculate now, and they say log y against log x. So h is log x, v is log y, and we quickly do. Yeah. First, we do the x first. Log 2, you get 0.301. Log 8, you get 0.903. Log 14 is 1.15. Log 20 is 1.3. Then next one, we calculate log y. Log 33 is 1.52. Log 5.07 is 0.705. Log 2.38 is equals to 0.377. Log 1.47 is 0.167. So we have 4 points to sketch. Then we sketch it here. Yeah. X when, yeah, 0.3 and 1.52. Yeah, we marked here. This is our first point. 0.903 around here, and 0.705. So it's here. Then 1.15 around here, and it's 0.377 is around here. 1.3 and 0.167. Okay. Then we are supposed to draw a line. Yeah. Okay. We draw a line. I think it's quite okay here. Yeah. We draw that line. Next step. we must find 2 points on the line, the one that is easy to calculate. What point is easy for us to calculate? Maybe around 0.6, yeah? 0.6. And we wait there. 0.6, maybe 1.1, yeah? How about another number, the one that is easy to read? 1.2. It's not really going to be accurate. But let's say, okay, 0.27. Yeah, I think so. So it's about 0.2. Yeah, we pick 2 points from graph. The question asks you to find, the question asks you to find, to draw, which we did. Then the second part is use your graph to estimate the value of k and n. We still can do that. How we do that? We find 2 points on the graph, and we find the gradient for it. We find m and c. M is y2 v2 minus v1 over h2 minus h1. So 1.1, 0.27 divided by 0.6 minus 1.2. If you use calculator, you get negative 1.40. So that is m. Yeah. Later we must make the equation p equals to mh plus c. Oh. Okay. Then c is equals to p1 minus mh1. We substitute here. p1 maybe we put this one. This is p1. Then this is h1. 1.1 minus negative 1.40 times h1, 0.6. Then we just calculate it. So this negative and negative is positive. You get 1.94. Then we find the equation. Because we have m and c, v is equals to negative 1.4 h plus 1.94, which is c. Okay, the question asks for the value of k and n from this equation. Y equals to x power n, or y times x power n equals to k. So we must work this thing out. We must work this thing out to find n and k. Very simple. Replace v with log y and h with log x. So we copy the number. Log y equals to negative 1.4 log x plus 1.94. Okay. Then the x and y, we shift to one side. So log y equals to log y plus 1.4 log x equals to 1.94. This negative turn into positive. Yeah, because you shift to left. Then these two logarithm, we combine into one. become log y times x power 1.4. That coefficient of log x become the power. Then 1.94, we change it into log 10 power 1.94. We remove the log for both sides. Y times x power 1.4 is equals to 10 power 1.94 is, we use calculator, 87.1. Okay. Is there? That means if we compare with the equation from the question, n will be 1.4 and k is 87.10. That's it. They ask you to find k and n. We find k and n using algebra. Yeah, and we also need to draw. Your answer might be a little bit different from mine because the way you draw the lines will be different. Yeah, but it's supposed to be near, not too much different.